So welcome back to the concept lab. Today we will be discussing the second part of ICSE class 9 physics motion in one dimensions. So in our last class we discussed about scalar, vector, motion, rest, and we discussed about what are the dimensions. In today's class we will be discussing about displacement, velocity and acceleration and stuff like that. So since we are learning about motion in one dimension, we will be just learning about a motion in a straight line only. So this is going to be an easy chapter and stick with me, we can learn together. So what's a displacement? So displacement is the shortest straight line distance from the starting point to the ending point of an object along with its direction. Let's understand it with a simple example. Imagine you walk 3 meters east then 4 meters west. So what is the minimal displacement? So you actually walked through 7 meters. Why? Because you walked 3 and again you walked 4. Now if I ask what is distance, you would say 3 plus 4 is 7. Now what if I ask what's the displacement? The displacement is 1 meter. Why? Because displacement only cares about your initial position and final position. So if this is your initial position, this is your final position. So distance between the initial and final is 1 meter. That's why displacement is a vector quantity. It has both magnitude and direction. So now that we know what distance and displacement are, let's see the difference between them. Imagine you walk from your home to a shop by taking a curved road of 500 meters. The distance you traveled is 500 meters because distance is the actual path covered. But if the shop is only 300 meters away from your home in a straight line, then your displacement is 300 meters towards shop. So what's the difference? Distance is the total length of the path traveled. It only has a magnitude. So it is a scalar quantity. Displacement is the shortest straight line distance from the starting point to the ending point, along with its direction. So it is a vector quantity. Now that we know the difference between distance and displacement, understanding speed and velocity becomes very easy now. Imagine two students are walking. The first student walks 100 meters in 20 seconds. And the second student also walks 100 meters in 20 seconds. Both of them are covering the same distance in the same amount of time. So their speed is the same. Speed is simply the distance traveled per unit time. In other words, it tells us how fast an object is moving. Speed has only magnitude, so it is a scalar quantity. Now let's talk about velocity. Velocity is displacement per unit time. Unlike speed, velocity tells us how fast an object is moving and in which direction. For example, if a car is moving 60 kilometers per hour towards the north, then 60 kilometers per hour is its speed, while 60 kilometers per hour north is its velocity. So remember this simple trick. That means speed is based on distance and has no direction. Velocity is based on displacement and always includes direction. That's why speed is a scalar quantity whereas velocity is a vector quantity. Now let's look at a different situation. Suppose the displacement is the same, that is 100 meters, but different people take different amounts of time to cover it. For example, the first person covers 100 meters in 1 second. The second person covers 100 meters in 2 seconds. The third person covers 100 meters in 4 seconds. The displacement is exactly the same in all three cases. The only thing changing is the time taken. Now let's calculate the velocity. 100 divided by 1, 100 meter per second. The 100 divided by 2, 50 meter per second. 100 divided by 4 is 25 meter per second. Now, did you notice something else? As the time taken increases, the velocity decreases. So even though the displacement is the same, taking more time means moving with a lower velocity. This clearly shows that velocity depends on both displacement and time. The greater the time taken for the same displacement, the smaller the velocity. So the velocity can be defined as displacement time taken. So displacement by time taken is called velocity. Now what about speed? Speed can be defined as distance divided by time taken. So here's a question for you. And just a small hint, average velocity is equal to total displacement covered in total time. Now let's understand acceleration. Until now we have learned about speed and velocity, but what if the velocity itself starts changing? Imagine a car starts from the rest. After 1 second, its velocity becomes 10 meter per second. And after 2 seconds, it becomes 20 meter per second. After 3 seconds, it becomes 30 meter per second. After 4 seconds, it becomes 40 meter per second. Notice what's happening. The velocity is increasing by 10 meters per second every second. This change in velocity with respect to time is called the acceleration. So acceleration in simple words is acceleration is the rate of change of velocity. Here the velocity changes by 10 meter per second every second, so the acceleration is 10 meter per second square. Suppose an object starts with an initial velocity of u. After moving for t seconds, its velocity becomes v. The change in velocity is simply final velocity minus initial velocity, that is v minus u. Now we already know that acceleration is the rate of change of velocity, which means acceleration is equal to change in velocity by time taken. This is v minus u by t. Acceleration is equal to v minus u by t. Now taking the time to the left side, we get at is equal to v minus u. This simply becomes v is equal to u plus at. Now this is the basic fundamental equation relating acceleration and velocity. So far we have understood what displacement is. But now let's learn how to calculate it. Imagine an object is moving with a constant velocity. If the object moves with a velocity v for t seconds, then every second it covers the same displacement. For example, in 1 second it covers v meters. In 2 seconds it covers 2v meters. Can you see the pattern? The total displacement is simply the velocity multiplied by time taken. Therefore, displacement is equal to velocity multiplied by time. Or mathematically, S is equal to Vt, where S is equal to displacement, V is equal to velocity, and T is the time taken. So in today's class, we have learned what distance, displacement, speed, velocity, and acceleration is. So keep learning and see you in the next video.